Hello everyone, welcome to Ekeeda platform, and this is Ravindra Jangid here, your electrical faculty. And in this video, I'm going to talk about the rating of the filter, how we decide and what are actually the rating of the filters. If we talk about the AC filters and the DC filters, so we will talk about one by one, and I have come up with some of the important points related with this topic. So let's crack one by one. So if we talk about this first point, it is going to say that let's firstly read that that is the voltage and the current stresses of the AC filter consist of the fundamental frequency and the harmonic frequency components. It is saying that if we talk about the AC filters, so it will have the voltage and the current stresses. It will have the voltage and the current stresses, which actually consist the fundamental frequency and also the harmonic frequency components. Fundamental frequency we have already discussed, that is omega. If I talk about the harmonic frequency, that is omega h, or you can say omega r. That is a resonance frequency, and where we have also used the h variable also. So it will have the fundamental frequency, along with that it will have the harmonic frequency components. Next point, it is necessary to determine the highest steady state current and the voltages for each filter component based on the calculations performed over the entire operating voltage range. It is going to say that it is specifying that if we have if we are willing to consider or calculate a rating of the filter, so sometimes it is necessary or mandatory to determine the highest steady state current, or you can say the voltage, and that should be consideration for each and every filter component, and which is based on the calculations performed over the entire operating voltage range. That is actually important one in this line. Okay, now we will move for the third one. The study of the transient voltages and the current stresses enable the computations of the energy duty of the filter resistors and the arresters, in addition to the insulations levels for all the filter components. It is specifying the points that if we are considering our filters, okay, then we are taking the considerations of the insulations level. That's why we are sometimes using the insulation coordination technique for the components. So in addition to that, the study of transient voltage, it means we generally do the study related with the voltages having the voltage transients and the current transients stresses, which actually enable the computation of the energy duty, which actually enable the computation of the energy duty of the filter. Okay guys, now to calculate the highest stresses, to calculate these highest stresses, the following cases are investigated, and these cases are actually the 4 cases which I have written here, and I am discussing one by one them. If I talk about the first one, so let's talk about the single phase. That is the first one, single phase ground fault. This is not the tute, single phase ground fault. So if we talk about the single phase ground fault, the fault is applied on the converter bus next to the AC filter. What does it mean? It means the fault is generally applied, or fault generally occurred on the converter bus. This type of fault generally occurred on the converter bus next to the AC filter. Whenever we have the AC filter next to that converter, it will be there. It is assumed, once again, it is assumed that the filter capacitor is charged to the voltage level corresponding to the switching impulse, the protective level of the AC bus arresters. So this is the point for the single phase ground fault. Now we will talk about the switching surges. This is also important one. So if you talk about related with the switching surges, so for the calculations of the stresses, for the calculations of the stresses due to the switching surges, Sometimes when the fault occurs, then the high amount of current to flow through the arresters, and these are the high surges having the high component of frequency, high oscillations due to inductor and the capacitor connected in the system. So it is, I can say, the calculations of the stresses due to the switching surges, the standard wave, the which generally we consider, the standard wave will have the 250 and the 2500 microsecond with a switching impulse protection level of the AC arrestor is applied at the converter bus. So what we apply for the AC bus converter is applied to a converter bus, that is the AC bus arresters. It will have the switching wave, how much? 250/2500 microsecond. Clear, guys? So that much of time period it has. Now it means it will have you can say the high frequency components. The filter energization, if we talk about the filter energizations, so firstly we will read that to determine the maximum inrush current for the AC filters, they are energized at the instant of the maximum, or you can say the peak voltages at the filter bus. I hope you have understood. So that is to determine the maximum inrush current. If we are interested in determining, because that is actually required for the rating of your filters. So if we want to determine the maximum inrush current for the AC filters, they are energized at the instant of the maximum, or you can say the AC peak voltage at the filter bus. Okay, guys. Now the fourth point, the fault recovery after the three-phase ground fault. So this point, so I have written or consider the 3 points in this category. The first point is saying to determine the maximum energy stresses. What? That is the maximum energy stresses for the filter, arresters and the resistors. The various fault clearing scenario are considered. And this scenario, the sum of these stresses or some of these scenarios, the HVDC converters are actually blocked after the fault initiation. Whenever there is a fault initiation in your system, so what we'll do, this is kind of the protection system also. The filter is kind of doing the protection system also, and it is you can say due to these filters, the HVDC converters are blocked after the fault initiation. It means the when the fault has occurred in your system. Okay, and this is because of the stresses on the your system or AC filters and the DC filters. Okay, guys. Now in this case, the load rejection by the blocking of HVDC converter result in the temporary over voltage. It means for the short duration of time there will be a high voltage level will be there. That's why we require the high insulations values, and these are kind of surges. Okay, it will also carrying the high voltage value also with a high content of non-characteristic harmonics. So these are actually the temporary over voltages. And also containing the non-characteristic harmonics. What is the non-characteristic harmonics? That it will not follow the NP plus minus 1 relations. So due to the, okay, so that is non-characteristic. So non-characteristic harmonics due to the transformation saturation, obviously it will going to be this transformer to be saturated, and low harmonic resonances between the filter and the AC network. So there will be a low harmonic resonance. There will be a resonance, but there will be a low harmonic resonance, which we have discussed in the last lectures. Okay, so resonance related with the harmonics we have already discussed. So I hope you have understood all the points which are listed for the rating of your filters. So tata, bye bye, and thank you.